So now we're going to look at actually sketching the graphs of rational functions. So if we have a rational function, we go through these steps to sketch the graphs by hand. We're going to find and plot the y-intercepts, if we have any, by evaluating the function when x is equal to 0. We're going to find and plot the x-intercepts, again, if we have any, by solving the equation, taking the numerator of our rational function and setting it equal to 0. We can find and sketch the vertical asymptotes by looking at the equation the denominator of x equals 0. We can find and sketch the horizontal asymptote, if we have one, by looking at those rules, looking at the degrees of our function, comparing them. We plot some more points in between to get a good idea of what's going on. The more points we have, the better, more accurate our graph is. And then we connect the points with a nice smooth curve, using our asymptotes as guidelines to help us complete our function drawing. So if we look at the function f of x equals 1 over x minus 3, first thing that we're going to do is find the y-intercept by evaluating our function at 0. So f of 0 would be 1 over 0 minus 3, or negative 1/3. So our y-intercept is at 0, negative 1/3. That gives us a point. So we'd have a point about here. Then we're going to find the x-intercepts, if we have any. And to find the x-intercepts, we just need to take the numerator of our function and set it equal to 0. So here we'd have 1 equals 0, which cannot be true, which means we have no x-intercepts. After that, we want to look for vertical asymptotes, if we have any. So we take the denominator of our function, set it equal to 0. So x minus 3 equals 0. Means that x equals 3 is a vertical asymptote. So here where x equals 3, we'll have a vertical line. And of course it's not going to behave itself, notability here. Here we go, there's our vertical line. And it's not actually a part of our function, it's just a guideline for our function, telling us we're going to come closer and closer to this line, but not actually touch it, not actually cross it. And then we want to see if we have a horizontal asymptote or not. So we compare the degree of the numerator and the degree of the denominator. Degree of the numerator, we don't have any x's, so it's 0. Degree of the denominator, we have x, so it's x to the first power, or 1. So n is less than m, 0 is less than 1, which means that y equals 0 is a horizontal asymptote, according to our rules. So we have a horizontal asymptote here on the x-axis. So that's another guideline for our functions graph. It's going to come closer and closer and closer to that, but not actually cross it, not actually touch it. So then we just want to come up with some more points here. So these vertical asymptotes, you want to pay attention to them. They kind of cut your graph up into pieces. We have one vertical asymptote, so we can look at the left of that vertical asymptote and the right of that vertical asymptote. We can pick some values and pick as many values as we want. The more points we have, the better, the more accurate it is. So if we look at to the left of our vertical asymptote, we pick some x values, plug them into our function to get some y values. We could pick like 2 and 1. We already know what we have at 0. So if we put 2 in, we'd get negative 1. If we put 1 in, we'd get negative 1/2. So we can kind of see what's going on with our function over on that side. We're going to be coming up as we move to the left and towards that horizontal asymptote. We're going to be going down towards our vertical asymptote. And then we want to look to the right of our vertical asymptote. We don't know any points to the right of our vertical asymptote, so we're going to probably want to pick more values over there. So to the right of our vertical asymptote, we have like 4. If we plug 4 in, we get 1. 5. If we plug 5 in, we get 1/2. 6. If we plug 6 in, we get 1/3. So then we may want to plug in something closer to our vertical asymptote, like if we did 3.5, we'd get 2. So we can see what's going on the right side of our vertical asymptote. We're coming up as we move towards a vertical asymptote that way. We're coming down towards this horizontal asymptote. And that's our graph. It's our entire graph. So let's try another one. If we want to sketch the graph of the function f of x equals 1 minus 3x over 1 minus x. Don't start doing anything until your function is in standard form in the numerator and denominator. So here we would really rewrite this as negative 3x plus 1 over negative x plus 1. And now you can start going through all those steps. So first thing we want to do is look for any y-intercepts. So we take the numerator of our function, set a equal to 0. Or sorry, no, we evaluate our function at 0. So we'd have negative 3 times 0 plus 1 over negative 0 plus 1, which would give us 1 over 1, which is just 1. So at 0, 1, we have a point, a y-intercept. Then, when we look for our x-intercepts, we put the numerator of our function equal to 0. So we take negative 3x plus 1 and set it equal to 0, which would give us negative 3x equals negative 1, or x equals 1/3. So here we do have an x-intercept at the point 1/3, 0. So about here. Then we want to look for any vertical asymptotes if we have them. So we want to see what values would make our denominator equal to 0. So if we take negative x plus 1 and set it equal to 0, we could see that negative x equals negative 1 or x equals 1. We do have a vertical asymptote. Here where x equals 1. Vertical asymptotes are not actually a part of our graph, so we make them dotted lines. They're guidelines for us when we're drawing in our functions. Then we want to know if we have a horizontal asymptote or not, so we look at the degree of the numerator and the degree of the denominator. Here we have x to the first and x to the first. So since these two things are equal, we need to look at the ratio of the leading coefficients. So here we would look at the leading coefficient of the numerator over the leading coefficient of the denominator, a sub n over b sub m. That would be negative 3 over negative 1, or positive 3. So y equals 3 is a horizontal asymptote. It's all the way up here. And again, this is not actually a part of our function, so it's not a solid line. It would be a dotted line. It's a guideline for us to draw our function in. And then again, it's just a matter of picking some more points to plug into our function. So here we have one vertical asymptote, splits our graph into two pieces really. You want to look at either side of that asymptote when you're finding more points. So if we look to the left of our vertical asymptote, we pick some x values and plug them into our original function to get some y values. We could pick, let's see, we have -1. I've already got a couple points over there. If we plug -1 in, we'd get 2. So we can already really tell what's going on that side of our function. We're going to be coming up towards our horizontal asymptote here and down towards this vertical asymptote. And then if we look at the right of our vertical asymptote, pick some x values, plug them in to get some y values. On the right side, we could plug in 2. That would give us 5. We could plug in 3, and that would give us 4. We could plug in 4, and that would give us 3 2/3. So we have 3 points over here. We get a good idea of the shape of our function. So as we move towards that vertical asymptote, we're going to be going upwards. As we move off to the right, we're going to be going down towards our horizontal asymptote.